Experiment number 7b, voltmeter. Let us convert given galvanometer into voltmeter of required range 0 to 3 volt and verify the same. Come to the observation. First point, resistance of the galvanometer G equal to 100 ohm. Second point, figure of merit of galvanometer K is also given 20 into 10 raised to minus 6 ampere per division. Then third one, we know that number of divisions on either side of 0 of the galvanometer scale is n equal to 30 division. Then fourth one, we have to calculate Ig equal to n into K, that is current required for producing full scale deflection of n divisions. N into K, n is 30, K is 20 into 10 raised to minus 6. So Ig value is 600 into 10 raised to minus 6 ampere. Then fifth point, maximum voltage to be measured is V equal to, we can take 1 volt or 2 volt or 3 volt. Now first we go for the calculation. In the first trial I am going to consider voltage 1 volt. In the second trial voltage 2 volt. In the third trial voltage is 3 volt. For 1 volt, first we go for the calculation. We know the formula for conversion of galvanometer into voltmeter, that is R equal to V by Ig minus G. V is taken 1 volt, Ig value is 600 into 10 raised to minus 6 minus G value is resistance of the galvanometer 100. So 1 divided by 600 is 0.001666. 10 raised to minus 6 will go to numerator. It becomes 10 raised to plus 6 minus 100. We can move the 6 points here. Now it is 1666.66 minus 100. R value becomes 1566.6 ohm. This is for 1 volt. When voltage is 1 volt, R value we have to apply is 1566.6. The same procedure we can follow for 2 volt. Voltage V equal to 2 volt, same substitution here. So in place of V2 divided by 600 into 10 raised to minus 6 minus 100. After calculation, R value becomes 3233.3 ohm. Now come to the third trial, V equal to 3 volt. R equal to V by Ig minus G. V is 3 divided by 600 into 10 raised to minus 6 minus 100. After calculation, R value is 4900 ohm. Now for all the 3 trials, these are the theoretical value of R. Now experimentally we have to prove the value of R for all the 3 values. Now come to the circuit connection. BA represents battery, plug key, rheostat, galvanometer connected in series with high resistance R, and V represents voltmeter. Connection should start from battery positive. At battery positive, let us take 3 wires. One wire will go to rheostat lower end, second wire will go to galvanometer positive, third wire will go to voltmeter positive. Then voltmeter negative and resistance box both are connected to rheostat, and galvanometer negative terminal is connected to another terminal of the resistance. Now from another lower end of the rheostat to plug key to battery negative. The same circuit connection we can observe in the experimental setup. Now this is DC power supply. The connection must start from battery positive. This is battery positive. We have taken 3 wires at the battery positive. So now you can observe one wire will go to lower end of the rheostat, second wire go to galvanometer positive, and third wire will go to voltmeter positive. 3 wires you can observe, one go to lower end of the rheostat, another wire go to galvanometer positive, and third wire go to voltmeter positive. Now galvanometer another end means you can take negative terminal of the galvanometer is connected to R. Now it is connected to R value. Now from voltmeter negative and also resistance another end. voltmeter negative and resistance another end. These two wires are connected to upper end of the rheostat. Then lower end of the rheostat. So this is connected to plug key, and another end of the plug key is connected to battery negative. This is the circuit connection. Now let us switch on the battery using rheostat. First we have to set the voltmeter. Voltage should be 1 volt. Now you can observe I am using rheostat to set the voltage for 1 volt. Now it is exactly 1 volt. Then this is high resistance box. We have to change the value of R value until the needle of the galvanometer must come within the scale. Observe, voltmeter is 1 volt, but galvanometer needle is out of scale. So this needle has to come within the scale. We have to reduce the current by supplying high resistance in series. We have calculated theoretical value for 1 volt. For 1 volt the answer of R is 1566.6. Now according to that value, let us change this R value. Now it is into 1000. Now I am setting for 1000. 1 into 1000 is 1000. Now I am changing the value of 100 ohm, 100, 200, 300, 400. In this way we have to change until needle of the galvanometer should come to 30th division. Now it is still out of scale. Now I am changing to 1500, and now this is 600. Now for 1600 the needle is still out of the scale. So but the voltmeter needle you can observe, so it is, the needle is not exactly at the 1 value. Now let us use rheostat again, set voltage for 1 volt. Now observe the galvanometer needle. The needle is exactly on the 30th division. Now when the division is 30, we can note down the R value. Here you can observe how I change the R value. So I have changed 1 into 1000 is 1000. Now I have changed the 100 value. Now it is 6 into 100 is 600, 1600, and I have changed the 10 ohm value. Now it is 6 into 10 is 60, 1660 is our R value. For the first trial, for 1 volt, theoretical value is 1566.6 ohm. Experimental value, now we got R dash equal to 1660 ohm. Now go for the second trial. We have to set voltage for 2 volt. So now using rheostat, I am setting the voltage for 2 volt. Now the voltage is 2 volt. For 2 volt, observe the galvanometer. The galvanometer needle is out of scale. Now it has to come exactly at the 30th division. For that we have to change the value of R. For 2 volt, I am changing R value. This is 3 into 1000 is 3000. I have changed the 100 value, that is 5. 5 into 100 is 500. 3500. For 3500, you can observe the needle of the galvanometer. It is exactly 30 and voltage is 2 volt. For the second trial for 2 volt, theoretical value is 3233.3 ohm. Now experimental value R dash equal to 3500 ohm. Same procedure, we go for the last trial. Now using rheostat, let us set the voltage for 3 volt. Now the voltage is 3 volt using rheostat. Observe the galvanometer needle. The needle is out of scale. Now we have to change the value of R. Let us change the value of R until the needle of the galvanometer comes to 30th division. Let us make it all the values 0, 0, Now let us change the value of 1000, 2000, 3000. Now it is, I am setting for 4000, and let us change the value of 100 until the galvanometer needle should come to 30th division. Now the R value is, we set for 5 into 1000, 5000 plus 3 into 100, 300. 5300 ohm, this is R value. For this, voltage is 3 volt and needle of the galvanometer is 30. So now the value of R is 5300. Theoretical value for 3 volt 4900 ohm. Now we got experimental value 5300 ohm. So these are the 3 trials we have taken. Theoretical values and experimental values, R and R dash both are nearly equal.